So here we have a question asking us to draw a rather nasty looking tree diagram. Lots of probabilities, all sorts of scope for error. I may have made a few myself, I don't know, we'll see. So let's look at part A first, which is to draw a tree diagram. So we've got two bags, bag A and bag B. I'm drawing bag A as an amber coloured bag and bag B is a blue coloured bag. And we've got 5 2p pieces and 3 pennies in bag A there, and 3 2p pieces and 6 pennies in bag B there. So the first thing we do is take a coin from purse A. So we could pick from bag A, we could pick a penny or a 2p, and the probability of those are 3/8 and 5/8 respectively. So having picked the coin from bag A, we now put it into bag B. So the bags now look like this. If we take a penny from bag A, let's say this one here, and put it into bag B, then this is what bag A and bag B look like now. Alternatively, if we take a 2p from bag A, let's say this one here, and put it into bag B, then this is what the two bags look like now. Okay, so we've picked a coin from purse A, bag A, and placed it in purse B. Now what we're going to do is take a coin from purse B. Okay, so purse B, we've got two versions of purse B. We've got this possibility, but we've also got this possibility here. With the first possibility, the probability of picking a 1 penny coin is 7 out of 10 because there are 7 pennies here and only 3 2p coins. So the probability of picking a 2p is 3/10. Here, this bag B here, or purse B, has got 4 2p coins in it. So the probability of picking a 2p is 4/10, and the probability of picking a 1p is 6/10. But now we're going to have a look at what happens when we take that coin and put it back into purse A. So if we took this penny coin here, let's say we take that penny coin from purse B and put it into bag A, then this is what the purses look like now. If we take a 2p instead from purse B and put that into purse A, then this is what the purses look like now. If we take a 1p, let's say this one here, and put that into bag A, this is what the, I keep saying bag, the purses look like now. And finally, that's what the purses look like when we take one of these 2p pieces, let's say that one, and put it back into bag A. So there's our tree diagram. Goodness. Okay, the second part of the question is asking what the probability is that purse A now has more money in it than purse B. Well, let's calculate quickly how much money each of the purses have under these different scenarios. So a quick count up tells us that those are the amounts, and these are the 3 scenarios where A has more in it than B. Now I could calculate the probability of each of these 3 events happening and add those 3 probabilities together, but it's actually quicker to say, well, it's the probability of those three happening is 1 minus the probability of this happening. And the probability of that happening is 5/8 times 6/10. So 1 minus 5/8 times 6/10 is 5/8. So that's the probability that purse A has got more money in it than purse B. Part C of the question, find the probability that the total value of coins chosen was at least 3p. Well, once again, we've got three possibilities. We've got picking a 1, then a 2, then a 1, or a 2, then a 2. In each of those cases, the value of coins was at least 3p. So again, I can use the shortcut. I can say 1 minus this choice. And so that's 1 minus 3/8 times 7/10. And that gives us 59/80. So part D of the question, a third coin is picked now from bag B. What is the probability of it being a 2p piece? So I'm using bag here as well. So bag, purse, bag. What difference does it make? Anyhow, we're trying to find the probability that it's a 2p piece at the end from bag B. So we've got 2p pieces here, and here, and here, and here. So it could be that we pick one of these first 2p pieces. The probability of picking a 2p piece there, 3/8 times 7/10 times 3, because there's 3 2p pieces, divided by 9, because there are 9 coins. So the probability of picking a 2p piece from this blue bag here is 3/8 times 7/10 times 3/9. We have to add to that the probability of picking one of these two 2p pieces, and that is 3/8 times 3/10 times 2/9. Then the third is the probability of these two things happening and then picking a 2p piece from this bag or purse, 4/9, and the probability 5/8 times 4/10 times the probability of picking a 2p from this bag, 3/9. So lots and lots of fractions there to manipulate. Luckily the calculator does all the work for us, and the answer we get is there. So there we are. Phew. I'm glad we got our, well, I'm not sure whether we did actually get our purses and bags sorted out, but it doesn't really matter.